Hello, my name is Mark Maeda. This is my final project for ECEN 160. We have a microprocessor here. I'm going to walk you through how to do it. So first off, I'm just going to go and show you it working. We're going to Control K there. Hello, Brother Nichols. 3 plus 4 equals 7. 3 times 3 equals 9. 4 minus 3 equals 1. And 4 minus 3 equals 1 again. We're going to go ahead and hit clear here. So as you can see, we have the parts of the counter here. We can clock through it to make it move. We can de-increment it, and we can clear there. The PROM code right there is in its ROM doing its thing. Our decoder is over here. Actually, is better. We have it set up here to go out to the various pins that it needs to go to. Register write enable, register write address, display write enable, register source select, accumulator, operation select, and subtractor, which most of these go to the ALU, so we'll go and check that out next. So actually we'll come down here. So as per the assignment, the most significant bits, 4 through 7 go into the decoder. 0, 3 go down into the MUX. The MUX selects between these bits here and the output from the ALU through the register select. Comes in here into our registers. Come over here. So there's the data in. We've got write enable address and write enable. As you can see, they're ANDed together, and you've got an inverter right here, so that when write enable is active but write address is 0, it goes to register 0. When write enable is active and write address is 1, it goes into register 1. And then the clock to make everything else work. Coming into the 4-bit registers. Standard 4-bit registers, don't really need to explain it, but here we are. Alright, come back here to main. Comes out of the registers. Register 0 and register 1 go into input for the ALU, along with operation select and the subtractor. Here I just noticed that there's a little loose guy there. I'll just have to do, there we go. Alright, got rid of that there. That was going to drive me insane. Alright, coming into the ALU, this jumbled mess. So we've got register 0 and register 1 coming in. As you can see, they come into the various, the adder, the OR, the AND, and the XOR coming in there. So we'll go and check these out real quick. 4-bit adder is made up of 4 1-bit adders, as you can see right here. The 4-bit adder has an added subtractor, which activates input into the XOR, and then so it inverts the number and then adds it, which is how you get subtraction in a bitwise adder. The bitwise AND is just some AND gates, bitwise OR, some OR gates, bitwise XOR, the XOR gates. Back to the ALU, comes in, goes through here. So the operation selector, I set it up with inverters to select. So 0, 0 is the AND, 0, 1 is the OR, 1, 0 is the and the 1, 1 is XOR. Coming in into the, I'm supposed to probably label this, the accumulator. Which is just another register. Just another 4-bit register. So the accumulator holds the information from the ALU and and we can select to move it from the ALU into either register 0 or register 1 through our decoder. Now, coming back over here, we also have in the decoder a register out. And this is 7 bits. From here, we just drop the most significant bit from register 1, and that comes out into here for the display. So walking through here, just going to go ahead and cycle this a couple times. So what's happening here, 8 and 4 are getting sent to register 0 and register 1, and then that's getting sent over to 30, meaning the display, which produces an H. When that is just how the AC2 code works in hex. Let's see where we can cycle through, keep cycling. Actually, I'm going to hit Control K here. All right, because this doesn't get interesting until we get into the actual adders. Okay, so as you can see here, we got 1D, 2, 3, 3, 0. That makes the equal sign. 1, 3, 2, 4 is how we move 3 into register 0 and 4 into register 1. 6, 0 is the code to move register 1 and register 0 into the ALU and use the add function. 4, 0 is to move the accumulator into register 0, and to display numbers on the screen, we have to have a 3 in register 1. So we move 2, 3, so we move 3 into register 1. Clock it and clock it, and that puts a 7 on the board there, because 4 plus 3 is 7. Then we move the 7 into register 0 and then 3 into register 1 to display 7. Let's see here. We can keep doing that. That's for line feed. We have an A 2030. All right. Come out with that here. All right, so to make a multiplication, we move 3 into register 0, 3 into register 1, then we add them together, and then move the accumulator into register 0, add another 3 into register 1, so we have 6 in register 0, 1 in register 1, add them together, move the accumulator into register 0, 2, 3 to put a 3 in register 1, and then display it, comes out with 9. Line feed again, and display 4, display minus. All right, so this one here is for that. Okay, so first thing we do, put 3 in register 0. Then we put F in register 2, and then 90 to XOR them together, and then move that into the from the accumulator into register 0. Put 1 into register 1, and then we're going to add them together. Now we do that so that the XOR inverts the number, so it's good because it'd be number 3 or XOR 1 1 1 1. And then we add 1 to that to turn it into the 2's complement of 3. So we add them together, move the result of that into the accumulator, move 4 into register 1, and then we add them together, move that into the register 0, 2, 3 to move 3 into register 1 to display the number, and then we display it as 1, which 4 minus 3 is 1, thank goodness. Line feed again, and then move 4 and 3, or actually we're just going to go ahead and do that here since we already know how to do this, because we've done it a couple times already in this video. All right, now we're gonna do 4 minus 3 using the subtractor. Way easier than the other method. So move 4 into register 0, move 3 into register 1, and then AO to activate the subtractor, and then 40 to move the accumulator into register 0, 3 to put a 3 in front of it to display the number, and then one more clock cycle to 30 to display that. All right, this has been my presentation for my microprocessor for ECEN160. Again, my name is Mark Maeda. Thank you so much for all of your help this semester. It has been a great class. Have a good one.